existence in the universe is both ordinary and special. The ordinariness of Earth is reflected in the fact that there are countless rocky planets in the universe, and Earth is just one of them. But the special point about Earth is that, to date, humans have not found life on any other planet. In other words, Earth is currently the only known planet where life exists. So the question arises, where does life on Earth originate from? This is a problem that has puzzled humanity, and currently only hypotheses can explain it. Regarding the origin of life on Earth, the scientific community currently holds two main viewpoints. The first viewpoint holds that life on Earth is unique, with no other life in the universe. The second viewpoint holds that the universe is filled with traces of life, and even life on Earth came from outer space. Although the first viewpoint sounds more convincing, the second viewpoint also has its own basis. Through research, scientists discovered that early Earth could not have generated life, because it lacked the necessary elements for life. Later, Earth was bombarded by small celestial bodies such as comets, asteroids, and meteorites. These celestial bodies brought to Earth many complex elements that formed life. For example, scientists previously found traces of microorganisms on a meteorite in Antarctica, determined that it originated from Mars, in addition to organic matter on other meteorites. Not long ago, the team of Japanese astronomy professor Akihiko Yamagishi published a paper in the journal Frontiers in Microbiology, stating that the universe may be filled with traces of life, and life on Earth also came from the universe. This conclusion was reached through an experiment that began in 2018. Specifically, researchers released a specially designed balloon aimed at detecting the presence of microorganisms in the atmosphere. The experimental result was beyond all researchers' expectations. The type of bacteria named Deinococcus was found at an altitude of about 12,000 meters above ground. Although the area more than 10,000 meters above ground is still part of the atmosphere, the radiation from the sun and the universe there is much stronger. Yet, microorganisms could still survive there. This shows that the limits of life's endurance far exceed what we know on the ground. Simultaneously, it also opens up a new awareness that life can exist in the universe. Based on the discovery in the atmosphere, Yamagishi's team proposed the dandelion hypothesis, meaning that life in the universe gathers like a dandelion flower. Once blown away by a certain force, its seeds will drift to every corner of the universe. When the time comes, the seeds will take root and life will sprout on other planets. Additionally, the research team also used the living conditions of microorganisms on the International Space Station as evidence. Some time ago, a space experiment showed what happens to a piece of culture medium, which had been processed, left outside the International Space Station for a month. After a month, there were still surviving individuals on it, despite radiation and other cosmic factors. Both of these discoveries show that life on Earth can survive in outer space under certain conditions, and also show that life can exist in places other than Earth. It can be said that among all types of organisms, microorganisms are the species that have broken the most human perceptions to date. A new study also shows that life may be common in the universe. The basic components of life can self-assemble under suitable conditions. This is called the process of abiogenesis, or the origin of life. Of course, we still do not know exactly how this process occurs. How life arises is one of the most fascinating questions about life, and it still puzzles scientists. To seek an answer to the above question, Tonori Kotani, a professor of astronomy at the University of Tokyo, wrote a new paper in the journal Nature Scientific Reports, with the title about the emergence of life in a primordial universe. According to the article, to understand this result, one must first grasp some concepts. First, the age and size of the universe continue to expand over time. Second, RNA, the nucleotide chain, requires a certain duration to be able to like most studies on the origin of life. This work also examines the fundamental components of life on Earth. That is RNA, not DNA. Although DNA dictates how life forms for each individual, DNA is much more complex than RNA. Therefore, it is likely that life emerged through the synthesis of RNA.
RNA is a molecular chain called a nucleic acid.
Some studies indicate that a nucleotide chain requires at least 40 to 100 nucleotides
to self-replicate, meaning to exhibit life. We might think that forming such chains is merely a matter of time. But current estimates show that the observable universe
cannot produce RNA chains as long as 40 to 100 nucleotides.
Observable universe. However, what is observed is only a part of the actual universe. In modern cosmology, scientists agree that the universe underwent a rapid inflationary period. This period created a vast region of space, far beyond our direct observation.
When incorporating the volume of this larger region into models of life's origin, the chance of life emerging increases significantly.
Our universe may contain over 10 to the power of 100 sun-like stars.
Meanwhile, the observable universe has only about 10 to the power of 22 stars. Specifically, 10 to the power of 22 is the number 1 followed by 22 zeros. According to calculations, the matter in the observable universe is only sufficient to produce RNA up to 20 nucleotides long. The inflationary process causes distances between parts of the universe to become too vast. As a result, most of the universe is unobservable,
because light from the Big Bang cannot reach us.
When cosmologists add the number of stars in the observable universe to the number of stars in the unobservable universe, they obtain a result of 10 to the power of 100 sun-like stars. This means that producing sufficiently long RNA chains
is not only feasible but even inevitable.
Professor Todani stated, "Here exists a quantitative relationship between the minimum length of RNA required to become the first biological chain and the size of the universe needed to produce these chains."
Like many in this field of research, curiosity and big questions have driven me. My recent exploration of RNA and cosmic history
made me realize there must be a reasonable way for the universe to transition from a non-biological state to a biological state, that is, when RNA can self-replicate. It is an intriguing thought,
and I hope my research can build on this to explore the origin of life.
Subscribe to the Hidden_Realms channel to see the latest videos.